Going on, guys? It's another episode of Mr. Dorrance Messy Garage. So, obviously, I'm not in school today. I've got training. So, I'm recording this last night, which to me is tonight, but you're watching this tomorrow. But for you, it's today. So, this is like some kind of a weird time paradox kind of thing. I don't know. Let's just get to the math, shall we? Okay. So, yesterday we finished up um, the previous set of sheets. And like I said, the thing yesterday, I was planning to do half yesterday, Tuesday, and then half on Wednesday. But y'all went and just blew right through it. Okay. I'm not complaining. I'm proud of you for doing that. I'm glad you guys are getting the hang of it. Because reducing fractions can be kind of tricky. Okay. I'm not gonna lie. It's it's confusing. And whenever I first started it, I was never sure if I had reduced them enough. Because trying to know, does six go into this or does three go into this, and how many times, and it's unsettling sometimes. Maybe that's the word I'm looking for. So if you look in the Google Classroom, which obviously you are because this is how you found the video. Okay, Doran, think. All right. You'll see KTF2 28. That stands for the workbook Keys to Fractions. So it's helping us to understand the fractions. So book 2, page 28, 29, and 30. Now, we might not get them all done today, but we're starting them today. Okay? Let's open up 28. Now, you guys also have the paper copies. Mr. Salyers, a good friend of mine. Don't mess with him. He was my student teacher last year. Okay? So I know that he knows what's going on, and he's worked with several of my guys repeatedly. It's in depth. So he knows his stuff. So if I say something that confuses you, ask him. He will get you straightened out. Okay? Mr. Salyers is a good guy. Treat him well, please. If you don't, I will hear about it. I will find you. Just kidding. I know I don't have to worry about you with you guys. Some of my other classes, but you guys I trust. Okay? I think we know each other well enough. Anyway, back to stuff. All right, let me open up my document camera here. Boom. Okay. So this is 28. This is the first page of our new packet. In fact, let me get one of my trusty pens, and I'm going to, first things first, right? Always put your name on top so I know who's getting the credit for it. Okay. So Pat and Sandy were asked to multiply 4/7 times 3/8. Now we just practiced this. We're familiar with it. We know what's going on. We can shrink this down. We can reduce it before we multiply it. And that makes life easier for everybody, right? Right. So both students expressed their answers in simplest form, but each one did the problem a different way. Pat wasn't quite sure how many times. Well, they both knew that 3 and 7 don't go into each other, so they couldn't touch that one. They had to reduce 4 and 8. Well, Pat wasn't sure just how many times to reduce it, so she reduced by 2. It went from 4. 2 goes into 4 2 times, and 2 goes into 8 4 times. Then she looked at it and said, wait a minute, 2 and 4, I could do that again. So 2 goes into 2 1 time, and 2 goes into 4 2 times. And when multiplied across, came up with 3/14. Now Sandy's like, oh, 4 and 8? Yeah, 4 goes into both of those. 4 goes into 4 1 time, and 4 goes into 8 twice. Let's multiply straight across. 3/14. So is one more correct than the other? They both got the same answer. Well, they're both correct. They're both 100% correct. But Pat just took an extra step to get there. If you're not sure how, what the biggest number is that will go into those numbers, what the greatest common factor is, if you know any common factors between these two numbers, start with that one. And then if you have to reduce it again and reduce it again and reduce it again, you can. Okay? It doesn't have to be, one stop and that's it. If it takes you 2 or 3 times of reducing to figure out which one is the lowest way to reduce it down, take all the steps you need to. It's faster if you can do it in one step, sure. But if you're not 100% positive, take multiple steps. It's still okay. See, they both got the same answer. On a test, they're both just as correct. May have taken Pat a little bit longer to get there, but I'm not sweating the time. You guys don't sweat the time. I want you guys just to make sure that you know that you know that you know what you're doing. Okay? If I was worried about the time, I'd have us rushing through everything, but I don't want us to rush. I want us to understand and I want us to know. You guys are like, dude, shut your pie hole. Get on with it. I want to get this problem done. All right. Sorry. I'm just gabbing over here. So if we look down here at the bottom of this page, there's going to be some numbers we can reduce. There's going to be some we might not be able to. Like 5 and 13, we can't reduce those. 9 and 18, we can. But we'll get to that. So it says multiply and express your answer in simplest form. Means we have to reduce the fractions, right? As low as I can get. Try to divide using the greatest common factor. If you don't pick the greatest common factor, you'll have to divide more than once. Well, that's okay. We could do that if we need to. We'll just see what happens, right? Okay, well, let's roll. Let's get into this. Let's give it a try. All right. So you have 11 30ths times 15 17ths. All right. 11 and 17. Well, those are both prime numbers. Remember we talked about prime numbers? The only things that go into it are itself and 1. It's like 2 won't go into 11. 3 won't go into 17. Not 4, not 5. There's no other numbers you can multiply to get 11 or to get 17. Or 3 or 5 or 7 or 13 or 19 or 23. There's a bunch of them, okay? A bunch of prime numbers. 11 and 17 are just 2 of them. They just won't reduce. So we're not going to worry about those. Those are going to have to stay where they are. Okay, 15 and 30. Well, I know 5 goes into 15, and I know 5 goes into 30. Because anything that ends in a 5 or a 0, 5 will go into, right? So if I reduce it by 5, 5, 10, 5, 10, 15. So 5 goes into 15 3 times. And 5 goes into 30, 5, 10, 15, 20, 25, 30. Goes in there 6 times. Okay, wait, hold up. Time out. Anybody catch my mistake there? Well, it's not a mistake. If I had left it like it was and finished it out, that would be a mistake. But there's more that I can do here, isn't there? Is there a number that goes into 3 and 6? Yeah, 3 does, right? 3 goes into 3 1 time, and 3 goes into 6 2 times. So just like what Pat did up here, maybe I didn't pick the biggest number right off the start, but if I try again, I can get there. So I've got this now reduced to a 1 and a 2. And we know 1's as low as it goes, so I can't reduce that down any further. So if I just multiply straight across now, 11 times 1 is 11. And 2 times 17, man, I'm glad I would have to multiply 6 times 17. Not this guy. It's a lot. Okay, so 2 times 17, that we can do. That's on your timetable chart. Not on the lefty-righty side, but on the uppy-downy side, you can find it. Lefty-righty stops at 16. But 2 times 17 is 34. So 11 over 34 is your most reduced version of this answer. Man, so that would be 165 over 510? I don't know, big numbers. I don't even think about that. Anyway, glad we can reduce it. All right, let's look over here. 3/8 times 4/11s. 3 and 11, do they go together? Look down your 3's column of your timetable charts, and you see 3, 6, 9, 12. Nope, skip right over 11. So these two won't go into each other. What about 4 and 8? I heard that. Yes, you are correct. 4 goes into 4 one time, and 4 goes into 8 two times. So multiply that straight. I'm sorry, this marker really doesn't show up that well unless it's got some shadow over it. That's very bad. Sorry about that one. All right, let me try this over here. If I get the light coming from a different angle, will that put some shadow on it? No, that washes everything out. Okay, forget it. Never mind. I'll lean myself over. There we go, like that. How's that? Okay. So 4 goes into 4 one time. 4 goes into 8 two times. Multiply that puppy straight across. I know I'm going to look at a 7. It's an arrow, not a 7. There we go. 3 times 1 is 3. 2 times 11, any single digit number times 11 is that number 2 times, right? So 2 and 2, 22. You got this. All right. I'm going to let you guys do this one. I'm going to let you guys do this one. So that's on you. That's on you. That's on you. All those. You guys are going to do all. Oh, would kind of help if you saw that, right? You guys are going to do all these on your own. And I know you can. I have great faith in you. I'm going to do this one with you. And then that's going to be that. Okay. This next page. Tell you what. This is going to be easy. So we'll do this page and the next page on Monday. All right. I got something else for you tomorrow. All right. Let me do this one with you. And then we'll get to rolling. Like I said, Mr. Salyers is great at math. He knows what he's doing. And you guys know what you're doing. If you guys have any struggles, any questions, he'll be more than happy to answer them with you. Use those timetable charts to help you out. If I had one right here with me, I would use it to show you how to roll through this. But anyway, yeah, let's do this. So 1/12 times 8/9. Well, again, we have that 1, so we can't reduce that. So that 1 and that 9, they have to stay where they are. They won't reduce. Okay? But 8 and 12, those will reduce. I know that 4 times 2 is 8, and 4 times 3 is 12. So I was going to take that in multiple steps, but I messed up. And I solved it the whole way at one jump. All right, so I'll do one more of these with you. All right. So anyway, that's just me. Way to go, Doran. Okay, anyway. So 4 times 2 is 8, and 4 times 3 is 12. See, I was going to break that down step by step and do 2 and then 2 again. Anyway, so when we've got that, multiply straight across. 1 times 2 is 2, and 3 times 9, check that one on your chart. Go to your 3's column, count down 1, 2, 3, 4, 5, 6, 7, 8, 9. You'll find 27. There we go. All right. Here we go. We'll do this right down here at the bottom also. And then you guys are on your own. No more help. Done. It's all you guys. All right. Use the timetable chart if you need to. 2 and 11. We talked about 11 being a prime number, so it won't reduce down by anything. And 2 goes in numbers that are 2, 4, 6, 8, and 0. And so that ends at a 1, so 2 won't go into it. So those are done. 9 and 27. All right. 3 times 3 is 9, and 3 times 9 is 27. So we'll reduce it by 3's. 3 times 3 is 9, and 3 times 9 is 27. Are we ready to go? What do you mean no? No, Mason, you said no, so I need to hear you explain it. Oh, whatever. Gabe, can you help him out, Gabe? Yeah. Okay. See, we're there. Brennan, is he right? Yeah, he sure is. Because 3 and 9, 3 goes into 3. 3 will cancel itself out, right? 3 goes into 3 one time. There's a 1. And 3 goes into 9 3 times. Okay, see, it took all of us to get together to answer this one. But we're there, right? 2, multiply straight across, times 1 is 2. And 3, multiply straight across, times 11. Remember, 11 is just going to be that number twice. Over 33. Boom! We got this. Okay, now you guys have 1, 2, 3, 4, 5 problems on your own. That's not going to take you very long, okay? Now, if word comes down that you guys got bored and started horse playing and gave Mr. Salyers a hard time, then I'm going to make sure we have to do twice the work next time. So don't give him a hard time. Get your work done. If you have any questions, he'll be happy to answer them. Other than that, just relax a little bit. We'll be good. All right, gentlemen. Have yourself a great rest of your day. And I'll see you as soon as I'm back. Where's my stop button? That's it. Bye.